All right, here we go with section 6.1. We're going to look at trig functions of acute angles. If you have a triangle and this triangle has a right angle, 90 degrees, and we pick some sort of angle here, traditionally we use the Greek letter theta. We also use the Greek letter phi when we're talking about angles. Actually, phi looks a little bit more like that. Okay. We have 6 trig functions that are associated with each of these angles. And it's all about being relative to the angle that you're looking at. Let's say that we're looking at angle theta right there. Now, we want to look at different sides of the triangle relative to angle theta. If we look at angle theta here, this side is called the hypotenuse. There we go. That's the hypotenuse, and the hypotenuse is always the longest side of the right triangle. If we are looking at this angle right here, on this side over here, this is called the opposite. And then this side right here, the one that actually touches this angle right here, this is called the adjacent. Now, these angles are always going to be in ratio to each other, and those ratios are going to be expressed using trig functions. First one we have is the sine of an angle, pronounced sine, but we use sin theta. And the sine of angle theta, and this is a function, traditionally we don't write the actual parentheses there unless it's something complicated, but we can leave the parentheses out. That is equal to the length of the opposite side over the hypotenuse. So whatever length this is, divide by whatever length this is the sine of angle theta. And here we are, angle theta right here. We also have the cosine, which we write cos angle theta, and that's equal to the adjacent over the hypotenuse. These are the two basic trig functions. We have the sine, which is the main one, and we have the cosine, which is a complement of sine. If you remember from geometry, you had complementary angles. Those are two angles that add up to 90 degrees. You had supplementary angles. Those are two angles that add up to 180. So the cofunction comes from the fact that it's the complementary angle. Now, we also have tangent. And we write tan of theta is equal to the opposite over the adjacent. These are the 3 basic ones. Now we also have the reciprocal functions. And those are secant, which is equal to 1 over the cosine of theta, which is going to be the opposite of this, or the reciprocal of that. So that's equal to the hypotenuse over the adjacent. We have the cosecant, and that is equal to 1 over sine theta. So that's going to be equal to the hypotenuse over the opposite. And then we're going to have the cotangent, which we write, and that's going to be equal to 1 over tangent theta. And so that's going to be the reciprocal of tangent. So that's going to be the adjacent over the hypotenuse. Now the abbreviations for all of these, for secant, we do secant theta. For cosecant, we write CSC theta. And for cotangent, we write COT theta. And so when we're talking about these trig functions, if we see SEC, we say secant theta. We don't say sin theta here, we say sine theta. Now, let's look at a typical example that you have where you want to find all 6 trig functions. Here's one of your homework assignments. And let's see if I can blow this up a little bit. Here we have a triangle. It's a right triangle. We have phi, and we have the sine of phi is we want to know what that is. So we're missing a side to this triangle here. And so we got to figure out what the side of that triangle is. We've got 22 here. We've got 17 here. We want to know what that guy is. Well, if there's any formula that you know, it's the Pythagorean theorem, where you have a squared plus b squared is equal to c squared. So we're going to use our Pythagorean theorem here to figure out what is the value of this side here. So I'm going to say 17 squared plus 22 squared is equal to c squared. My calculator, I'm going to do 17 squared plus 22 squared, and I'm going to get 773. I'm going to do the square root of that, and I'm going to get a value of 27.8. We're going to look for exact answers here, and so we're going to just say that's equal to, that c is equal to the square root of 773. Okay? So now, when we look at all of my sine functions, first I would want to try to see if I can reduce this or not, which I cannot. So I can't rationalize that at all. So it is what it is. So now I know I have, that's the square root of 773 over here. Pause this and rewrite it. Here's phi. Sine is the opposite over the hypotenuse. So that's going to be 22 over root 773. Can't leave a square root in the denominator, so we multiply by root 773 over root 773. So that's going to be equal to 22 root 773 over 773. So over here, we're going to do a fraction where we're going to have 22 root 773 divided by 773. We're going to check that answer, and great, awesome. So now we're going to do cosine. Cosine is the adjacent over the hypotenuse, so that's going to be 17 over root 773. We'll rationalize the denominator again by doing root 773 over 773, square root of 773. That's going to be equal to 17 root 773 over 773. So on our homework, we're going to do 17 root 773. Divide that by, all right, try that again. We're going to do, in a fraction, we'll do 17 square root 773 divided by 773, and bazinga. Tangent is going to be the opposite over the adjacent. So that's going to be 22 over 17. And we're going to write 22 over 17. The cosecant is going to be the reciprocal of sine. So all we got to do is flip this one. So that's actually going to be root 773 over 22. Secant is going to be the reciprocal of cosine. root 773 over 17. And then finally, cotangent is going to be the reciprocal of tangent. So it's going to be 17 over 22. All right, and we're done that one.